So this is the last section of 17. We are just going to distinguish between proportional and non-proportional relationships. So just identifying based off their characteristics. So all the vocab or key terms should be things we've already talked about, right? Proportional will have a constant rate and it will begin at the origin. Non-proportional, there we go, forgetting an O, will also have a constant rate, but it will not begin at the origin. And slope-intercept form will be a linear equation written in the form y equals mx plus b, where m is the slope and b is the y-intercept. We'll touch on that more tomorrow in class. And then linear is a graph that is a straight line. Remember the root word line right there, linear line. So take a moment, pause, make sure those are in your note takers. So this first one graph shows that the sales tax charged based on the amount spent on the video game store in a particular city. Does the graph show a linear relationship? So that's the first question, just is it linear? Remember, linear just means it's a straight line. So yes, linear. Second question, is the relationship proportional or non-proportional? So we know it's one of them because it's straight. That's what makes these true. It has a constant rate. That's what's going to keep it straight, right? If it's not at a constant rate, it'll start to make it curve or not be straight, basically, right? Have edges and things like that. So proportional will start at the origin. Non-proportional will not start at the origin. This does, in fact, start at the origin, so we would say proportional. That was pretty easy, huh? So the number of years since Keith graduated from middle school can be represented by the equation y equals a, take away 14, where y is the number of years and a is his age. Is the relationship between the number of years since Keith graduated and his age proportional or non-proportional? So remember, proportional relationships will be in the form y equals kx, or what we also could call it now at this point is y equals mx. And non-proportional it's a big long word to write, will be y equals mx plus a b. So you can see the difference is that after our x or after our variable, there will be something to make it non-proportional. So just pretend a, instead of a, it's x, right? So this is now y equals x minus 14. If we're worried about this plus, we can always change it to add the opposite. So now it's y equals x plus negative 14. Okay, we're getting close. And if we're worried about this m, we need to remember that there is an x there. There's at least one. So we would say y equals 1x plus negative 14. So now you can see it very much matches this. So we would say this is non-proportional. We really didn't need to go that far. The fact that it just has this end automatically makes it non-proportional as well. All right, so I want you to answer this question. Determine if each of the following graphs represents a proportional or non-proportional relationship. Pause, take a moment, proportional, non-proportional, or vice versa. Unpause, check your answer. So we would say this one is non-proportional. And I'm just going to write non-prop because it's faster. And that's because it doesn't start at the origin, right? No origin. And we would say this one is proportional, and I'm just going to put prop. Okay, and that's because it has the origin. So just things to remember, right? Proportional. The equation will just be y equals mx. I'll make that an arrow. Non-proportional I'm going to write non-prop will be y equals mx plus b, and the b is what's going to affect it. So here's your independent practice. Just determine based off of the fact that these just the equations, if they are proportional or not. And then we'll talk about and check those when we get back to class. So pretty simple, quick and easy. Make sure you're getting some Dreambox time done. It will be due Friday. See you next time.